November 2024, paper 1, variant 3. Question 1. A student uses a ruler to find the volume of the water in a tank. What other length does she need to measure? Okay, she measures EF and FG, right? What other, what other length does she need to find the volume? If she found EF and FG, she still needs what? She still needs FK. Yes, she still needs this length, the height or the depth of the water. Which statement is correct? Which statement? Speed equals distance times time. Speed is velocity in a given direction. Speed is velocity in a given direction? No, it's actually the other way around. That velocity is the speed in a given direction. Velocity is the speed in a given direction. So this is wrong. And velocity is distance over time. Velocity is the speed, but in a given direction. Stone falls freely from the top of a cliff. A resistance may be ignored. You have a stone falling from the top of the cliff. Can you tell me what happens to the acceleration? What is the acceleration? What is the acceleration of free fall acting on this stone? The acceleration of free fall acting on this stone is constant. This is an acceleration time graph. It's an so it's not A, actually it's D. Why? Because it's constant. It is 9.8 meters per second squared. It is constant acceleration. Okay, constant acceleration. The speed keeps on increasing. Yes, the speed keeps on increasing, but it's called a constant what? A constant acceleration. Okay. Which statement about weight is correct? Yeah, which statement about weight is correct? It is a measure of the quantity of a matter. Is it the gravitational force on an object that has mass? Yes, it is the gravitational force on an object that has mass. A student uses the equation rho equals m over v. What is rho, what is m, and what is v? This is density. Yes, density equals mass over volume. Density equals mass over volume. What is the point at which the weight of an object appears to act? Weight of an object appears to act. At which point? Appears to act. At the density of moment pressure, at the center of gravity. Okay? The center of gravity is the point at which the weight of an object appears to. Is all of the weight of the object concentrated in this point? No, it's not. All of the weight, it's not constant, but it appears to act at this point. A spring is stretched by adding loads. Which diagram shows the extension load graph? The extension load graph. Which diagram would show the extension load graph? Think about it. Is it A? Is it B, C, D? I guess C is wrong. D probably still wrong. The extension has to change with the load. Okay, is it A or is it B? It is B. Yes, because they are directly proportional. They start from the origin. It's not A. A would be if instead of extension you wrote down the length. You wrote down the length. Okay. Yes, so it is B. The diagram shows a force of 12 newtons being used to push a box. The box is moved 8 meters along the slope. This lifts the box a vertical distance of 2.5 meters. How much work, okay, is done pushing the box from the bottom to the top of the slope? How much work is being done in pushing the box from the bottom to the top of the slope? How can I do it? Work done equals what? Work done equals force times distance moved. Did he say what is the work done against gravity in this question? No, he did not say that. He said in pushing the box. While he was pushing the box, force times distance, 12 times 8, 96 joules. Force times distance. Which energy resource is non-renewable? Non-renewable. Ah, biofuel. Oh, it's a fuel, so it's not. No, this is biofuel. Biofuel, which is the wastes of the animals, animal waste. So it is actually renewable. Energy from the sun, water behind the dam. So it's only nuclear fuel. Nuclear fuel. Okay. What is the relationship between the power of a motor, okay, between the power of the motor and the force exerted? Distance, okay, how can I find the power? How can I find the power? Power equals what? Energy over time. Or you can say that power equals work done over time. What is the work done? Work done is the force times distance divided, right? So force times distance basically over time. Because we are talking about the mechanical power. This is the mechanical power. If he asked me about the electrical power, okay, if he asked me about the electrical power, I would say IV or VI. Okay, I times V, not I over V. It is I times V. This is if you're talking about the electrical power. If you have a circuit, you have the current, you have the voltage, you can find the power of the circuit. But if you're talking about the mechanical power would be work done over time or energy over time. How is pressure defined? Pressure is the force over area, right? So force per unit area. Force over area or force per unit area. A fixed mass of gas is trapped in a cylinder with a piston. The volume is slowly reduced. Okay? At a constant temperature, the volume is reduced. The volume decreases. Which statement is correct? Which statement is correct? The force exerted on the gas will decrease because the particles move more quickly or because the particles move more slowly. Do the particles increase or decrease their speeds? No, they do not. Okay? No, they do not. They do not increase or decrease the speed and they do not hit the piston harder. Hitting the piston harder requires them to move with a greater speed. So this is wrong and this is wrong and this is wrong. The only correct answer would be that the force exerted by the gas, okay, will increase. Why? Because they are hitting the piston more frequently. More frequently. Why? Because the area of the piston decreases, or the area of the walls inside decreases due to the decreasing volume. Due to the decreasing volume. Okay? The air temperature rises from 10 to 40. From 10 to 40. What is the change in temperature expressed in Kelvin? The change in temperature, not the final temperature. What is the change in temperature? It was from 10 to 40. So it increased by how much? It increased by 30 degrees Celsius. Right? It increased by 30 degrees Celsius. Can I find this in Kelvin? 30 degrees Celsius would be 30 degrees Kelvin as well. How did he do that? Is 30 degrees Celsius the same? Shouldn't we just add 273 so it would be 300? No. No. Can you repeat the question? Yes, I can repeat the question. So let's think about this question. If it was 10 degrees Celsius, in Kelvin, it would be what? Plus 273, so it's 283 degrees Kelvin, right? This is 10 degrees Celsius. Why? Because Kelvin is equal to Celsius plus 273. So I added 207. What about 40 degrees Celsius? What is 40 plus 273, right? 40 plus 273 is what? Is 313. So 313 degrees Kelvin. So it changed from 283 degrees Kelvin to 313 degrees Kelvin, right? Technically, it changed from 283 degrees Kelvin to 313 degrees Kelvin. What is the change in Kelvin? It would be 30 degrees Kelvin. It would be 30 degrees Kelvin. Minus 313 minus 283, which is 30 degrees Kelvin. That's it. That's it. Hmm. Which effect is not due to thermal expansion? Not due to thermal expansion. Convection currents in air. No, actually, convection currents in air has to do with thermal expansion. When the volume increases and density decreases, so it has to do with thermal expansion. Expansion of a bubble rising through a fizzy drink. As the bubble rises up, it actually expands. Is this due to thermal expansion? Does this have to do with heat? I think not. But let's check out the other answers. Expansion of a liquid in a thermometer. In a thermometer, yes. When the liquid expands, it expands due to the heat. So, yes, this is due to thermal expansion. This is due to thermal expansion. This is due to thermal expansion. Lengthening of an overhead power line in the summer. The power line, the distance, or okay, it does it lengthen due to the heat? Yes. Does the length increase due to the heat? Yes, it does increase due to the heat. So this is actually right. This is actually right. So the only wrong answer would be B. Why? Because the bubble, as it rises up from water, we're talking about water, as the bubble rises up, what happens to the volume? The volume increases. Why? Because the pressure decreases. As it rises up, the volume increases, because this is not, that's the thing, this is not related to thermal expansion. That's why this is the wrong answer. That's why this is the wrong answer. Okay, it doesn't have to do with thermal expansion. Okay, on a summer day, the level of the water in a pond falls. Water decreases. Which statement explains this? This is evaporation, right? Most energetic molecules escape from the surface and do not return. Right? They do not return. Right? Most energetic molecules escape from the surface. Question 16. You have a vacuum flask, which is used to keep liquid hot. You have a hot liquid inside this vacuum. How does the thermal energy pass through the vacuum? How does it pass through the vacuum? Conduction, convection, no, radiation only. Can conduction or convection pass through the vacuum? No, it cannot. It cannot. 17. Which row is correct? The wave with the largest amplitude, the wave with the largest wavelength. This is easy. The largest amplitude would be X. The largest wavelength would be Y. This is a longer, much longer wavelength. Right? Okay, which row shows an example of a transverse wave and a longitudinal wave? Transverse wave. Light, radio. Does it sound? No. Water. Okay. Longitudinal. Radio waves. No. Sound wave. Yes. Water. No. Light. No. So it's the only correct answer would be B. A ray of light is reflected from a plane mirror. Which angle is the angle of reflection? Which angle is the angle of reflection? Is it between the incident ray and the normal? Uh, light is not longitudinal. This is wrong. The angle between the incident, no, this is the angle of incidence. Angle between the incident and the reflected ray, nope. Between the reflected ray and the normal, yes. The reflected ray and the normal angle of reflection. Question 20. What is the nature of this image and can it be formed on a screen? Image that appears on the other side. Is it a virtual image? No, it's not a virtual image. It's a real image. Can it appear on a screen? Yes, think about it. If you have a projector, does the projector produce the image on the screen? Yes, it does produce it on the screen, so it is a real image and it can be formed on a screen. Which diagram shows the dispersion of white light? Dispersion of white light. This is easy. Can it be C or D? No. A or B? It is A. Why? Because the red has to be on top of the violet. Which row correctly compares microwaves and ultraviolet? Frequency. Okay. Frequency of the microwaves compared to the ultraviolet. Yes. Is the frequency of the microwaves higher or lower? Frequency of the microwaves. If you write them down, Rami, looks great. Microwaves compared to the ultraviolet. It has a larger wavelength, but a smaller or a lower frequency. The uses, okay, the uses of them. Would they be microwaves are used to heat water and ultraviolet used to sterilize water? Microwave to sterilize water and ultraviolet is to heat the water. Which is correct? Huh. Microwaves are used to heat water, yes. And ultraviolet sterilizing the water. Sterilizing the water, yes. Okay. Heating the water, microwaves, and infrared, you can say. Um, Sterilizing the water would be using ultraviolet. A pulse of sound is produced at the bottom of the boat. It is reflected and reaches the boat 1.3 seconds later. The sound, after it was produced, using this information, can I find the speed? Yes, I can find the speed. The speed would be 2 distance over time, right? This is an echo. This is an echo. So basically 2 distance over time. 2 times 1000 divided by 1.3. What would this give you? 2 times 1000 divided by 1.3, which is around 1540 or 1500 meters per second. Right? Diagram shows 3 small compasses. Which compasses show the direction of the magnetic field due to the bar magnet? Due to the bar magnet. You have P, Q, R. If you have a North Pole would produce a magnetic field from the North Pole to the South Pole, right? In this direction. Is P correct? No, it's not correct. Again, from the North Pole to the South Pole. Is R correct? No, again, it is wrong. Into the South Pole, yes, it's moving into the South Pole. So only Q. Only Q would be correct. صح؟ Hmm. A negatively charged rod is brought close to an isolated uncharged metal sphere. What are the charges on side P and Q of the sphere? P and Q. So if you have a negatively charged rod, would P be negative or positive? Would P be it would be positive. Why would it be positive? Because it's attracted, right? It is attracted to the negative sphere. What about Q? It would be negative because they are repelled. So P is positively charged and Q is negatively charged. Okay, it has to do with repulsion and attraction. Diagram shows a simple circuit. The ammeter reading is 2 amperes. The voltmeter reading is 6 volts. What is the resistance of the wire? R equals V over I. And R equals V over I. Right? The voltage is 6 volts and the current is 2 amperes. So the resistance would be 3 ohms. Yes, 3 ohms. Correct. Lamp is rated 240 volts, 0.4 amperes. Normal brightness for 1 minute. How much energy does it transfer? If you want to calculate the energy, you have the voltage, you have the current, and you have the time. Energy equals VIT. The time has to be in seconds. So if it's in minutes, you multiply by 60 to find it in seconds. 240 times 0.4 times 1 minute, but you have to multiply it by 60 to find seconds. 240 times 0.4 times 60, which is 5,760, almost 5,800 joules. Okay, 5,800 joules. What's wrong with 25? Again, this is a negative rod, right? Negative rod would attract positive. So P would be positive, but it would repel the negative electrons. So the negative electrons would move to Q. Negative electrons would move to Q. So Q has to be negative, while P has to be positive. Just a matter of repulsion and attraction. Okay. The attracted particles would be the positive particles. The repelled particles would be the negative particles. Question 28. Which circuit diagram is correct for the torch? Hmm. Which circuit diagram is correct for the torch? You have the battery, you have the switch, and then you have the lamp. The battery, the switch, and the lamp. Okay. You have two answers that seem to be correct, right? Two of the answers seem to be almost correct. A and B. C and D are wrong, right? C and D are wrong. Why? Because they are in parallel, and this torch seems to be in series, right? The whole circuit seems to be in series. A and B. Which of these would be correct? A or B? Hmm. Look at the cells in A and B. The cells in A are positioned correctly. Why? Because you have the positive on the right and the negative on the left. The positive on the right and the positive and negative, positive and negative, right? So it is A, but B, you have positive on the left and negative on the right. This is wrong. This cell is wrong. This cell is wrong in B. So it's actually A. A is the correct answer. Okay, which symbol represents the device that contains a current carrying coil in a magnetic field? A current carrying coil in a magnetic field. ايه ده? What is this? What's D? D is a fuse. It doesn't have a current carrying coil. What is C? C is a thermistor. It doesn't have a current carrying coil. What is B? It's a motor. Does a motor have a magnetic field? And does it have a coil? Does a motor have a magnetic field? Yes, it does. What about A? What is A? It's a heater. A is a heater, so it's not A. It is B. It is B. You have a magnetic field, and you have a coil which has a current inside it, which gives this motor the rotation it needs. It rotates the motor. It does rotate the motor. Okay, DC motor. Yes. Question 30. Diagram shows a three-core cable connecting a three-pin socket to an electric fire with a metal frame. Whatever, I do not care. The earth, live, and neutral connections of the socket are labeled E, L, and N. Earth, so this is the earth wire, this is the live wire, and this is the neutral wire. Okay? A switch is connected. Where is the switch connected? Where should we place the switch? Where should that's simple. We have to place the switch. We have to place the switch on the on the live wire, which is at P. That's it. That's it on P. Switch live at P. That's it. That's all you need to do. Right? Hmm. Okay. Now, moving on to question 31. What can she do to get a greater reading on the sensitive voltmeter? A greater reading on the sensitive voltmeter. What can she do? Use a stronger bar magnet. Yes, use a stronger bar magnet. Excellent. Excellent. Question 32. Which diagram shows the shape of a magnetic field pattern around the wire? Around a wire. You have wire into the paper, so it has to be A. Yes, it has to be A. Into the paper. It is A, definitely. Okay. What does a step-up transformer increase? Step-up transformer It increases what? Step up voltage. Yes, step up transformer increases the voltage. Thank you. When measuring the emissions from a radioactive rock brought into the laboratory, a teacher mentions that background radiation must be taken into account. Background radiation must be taken into account. What is this background radiation? Is it the infrared? No, it's not the infrared radiation, definitely. Ionizing radiation from the radioactive rock brought into the laboratory, or ionizing radiation in the laboratory when the radioactive rock is not present. If you have uranium, for example, or something, yes, the background radiation is the amount of radiation that is already present without any other radioactive sources. It is there due to the natural occurring objects such as the sun, such as the trees, the food, the drink, whatever, okay, without any other radioactive sources. How do the ionizing effect and the penetrating ability of alpha particles compare with those of gamma or beta? Yes. Huh. Ionizing effect of the alpha is what? It's higher, right? Penetrating ability of alpha is lower. It is A. Yes, it is A. Half-life is for the something of a sample of radioactive isotope to half. Which words correctly complete gaps 1 and 2? Half-life is what? It is the time taken or the half of the time taken? It is the time taken. Yes, it is the time taken for the nuclear number or the number of nuclei. Is it the nuclear number? No, we do not actually care about the nuclear number itself. We care about the number of atoms there are. We care about the count rate there is. Okay, so the number of nuclei, the number of atoms, total number of atoms that are in the sample that we have. Okay. Radioactive materials must be handled in a safe way, which is not a safety procedure. Not a safety procedure. Storing radioactive materials in cardboard boxes. Do we store them in cardboard boxes? No, we don't. We store them in lead boxes, right? So this is not this is a wrong safety procedure. 38. The solar system contains 8 major planets. What is the correct order of 3 of the major planets, starting with the planet furthest from the sun? Furthest from the sun. Okay. Neptune, then Jupiter, then Saturn. Neptune. Can we write them down? Can we write them down? My very excellent mother just sent, okay, just served us noodles, right? My Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. So with the furthest planet, I shouldn't start with Mercury. Neptune, okay. Jupiter, not okay. Neptune, Neptune, right? And then Jupiter, then Saturn, or Saturn, then Jupiter. So this is wrong. Mars, then Earth. This is the correct order for these 3 planets. Okay, Neptune, Mars, and then Earth. This is the correct order. Okay. 39. The diagram shows a radio signal from Earth being reflected by Pluto. Okay, by Pluto and returning to the Earth. The distance between Earth and Pluto is 0.005 light years. What is the time taken for the radio signal to return to Earth after being sent? After being sent. It would be after being sent. So it is 0.001 years. 0.001 years. Why? Because this is a reflection. It's an echo. Okay? It takes a time of 0.005. Okay, 0.005. And then another 0.000 Zero, 5, three zeros. Yes. So the total time is times 2. Yes, you multiply by 2. So it is C. It is C. The Milky Way is something made up of hundreds of something stars. It is a galaxy made up of hundreds of billions of stars. Okay.